Hello YouTube, welcome back to this series on the Crafting Interpreters book. And last time we handled the declaration of variables like this. So if we try to run our project, ignore all the errors, we can say something like x equals 2 and we can print expressions like this. But in this episode we will look at the assignment section of this chapter and basically which will allow us to mutate variables, I think. Okay, so the first thing we need is to add a new expression type to the language, which is that you can have an identifier equals something. And if I recall, it goes into not this one actually, but the parser. Yeah, so here we go. We have an expression which before was just an equality. Now it can be, now it's an assignment, and an assignment is something we still need to implement. So there's this interesting thing that assignment is an expression and not a statement, which I think means that it has a value and it's not just doing something. Yeah, so we added expression, so it just returns assignment. By the way, we also need to go in here and add a new type of expression. So we can add it up here, so it's alphabetical. And we need a name, which is a token, and we need a value, which is an expression. Okay, now we get into the parser code, and it's a little bit tricky apparently because we have to support things like this where we have to look ahead many tokens before we find out what it is we're parsing. So let's go into the assignment function here. Okay, that looks horrible. And first we pass equality, and then we see if the token, the next token, do we have this match token by the way? Yes, if it's an equal token, then equals is the previous one, value is, okay, interesting. Guess we could do this, and we want it to match with a variable which in our code just looks like this. name equal okay, we don't need that. It's kind of funny. So here we will just return an assignment, name and value. And for anything else, we'll throw an error, invalid assignment target. And if we don't get this match statement, then we will just return the initially passed expa. So what's happening here? First we will pass an equality. That will go down here, pass a comparison, and actually should do this. It will, and we should do okay. Pass a comparison. It will go here. Pass a term. It should eventually go here, I guess, and turn a variable. Okay, let's just try it for a second. Didn't work. Right. Need to box it. Okay. Do we need to wrap it in else, maybe? Now we have some errors in, for example, the print function, I guess. Yeah, this one. Yeah, I guess we will just return like name equals value. I think that should be fine. And this one we also need to toString. And it doesn't like that. Oops. Okay. Now in evaluate. How do we evaluate an assignment? I guess we need to go into the environment and overwrite the value. So we need to do something like this. And then we insert the leg seam and the value like this. How do we evaluate? Initial this. We can just call define. We have something. So we will define this and still think we need to do that. If the value was not there, then we have to return an error. Okay, let's try again. And what is the value of this? Thing. I think it should be this. Still some errors. Now it has to be mutable because we're changing it. There's something in here. Yeah, I was worried about this. Let's go into Expr line 149. Can we do something like if we limit the scope of the borrow? What is the problem here? We need that. Why am I even getting actually I don't need this, right? I don't need the value. I'm just checking whether it's there at all. Okay, this one needs another. So here value is a box. How do we get it out of the box? Wait a second. It's an expression, so we have to evaluate that expression. So we have to do something like this. And we can do this. All right, and we need to provide the environment. And it has to be a value. Now it's complaining over here. So we just clone it. Great. Then we also have to clone the value. It's not super nice. At least now the errors are gone. So now I can say A equals 2, I can print it. I can say A equals 5, I can print it. Okay, so we got that working. And actually this should not be a panic, it should probably just be an error. Like so. And I just want to show something, which is because of the way we set it up. If we say this, and then we can actually print, we should be able to print A equals 3, and it gives 3, because the value of an assignment is whatever you assign it to. I think it works the same way in C, so it's not completely crazy. So now we get into the last part of this chapter, and he's talking about how to extend the interpreter, but thanks to the Rust compiler, we have already added all these methods that we need to evaluate and to print and so on. So we actually probably don't need to read this. Okay, the next bit of thing we need to look at is scope. So basically, how long do variables live, and which variable is active where. So for example, here we can define A and print A, and it will print first, and here we define another A, which is distinct from that, so it has a different scope than this variable. Doing that involves some work with the environments and like temporarily active environments and so on. So I think we'll leave that for the next video. So until next time.